Hi everyone, it's Mrs. Griffin with the Unit 5 Lesson 10 video where we're going to talk about similarity transformations. And we're going to be describing how we can use rigid motions and dilations to map one figure onto another. Remember that our rigid motions are the ones that are translation, reflection, and rotation. They keep objects the same size. When we do a similarity transformation, then we're combining those with a dilation and ending up with similar instead of congruent figures. So to talk about a few different concepts that don't come up often, but they are interesting to mention. Similarity is reflexive because an object will be similar to itself. Reflexive always has to do with something and itself. So every triangle or other shape is similar to itself. Similarity is transitive, which is a lot like substitution, because if you have two figures that are similar to the same figure, then they are also similar to each other. And that's sort of like substitution. But because we're not talking about things being equal, we use the word transitive. And then similarity is symmetric, and this is going to be the focus of what we do in this lesson, because once you have a figure that is similar to a second one, there is something that you could do to map the image back onto the original. So symmetric means you could go forwards or backwards. That symmetric idea is what's going to lead us to inverse transformations. Inverse transformations are a series or just a single transformation that will map an image back onto its pre-image. So it undoes the original transformation. So if we think about these examples, number one, we have a translation along vector AB. So that means we move from point A to point B. If we wanted to undo that, we would go the other way. We would start at B and go back to A. We would go in the reverse direction. Also, add this in because this isn't an example, but it's important to realize. If we have a translation -2, 3, that would be like saying going left 2 and up 3. The inverse would be to do the opposite direction. Go back by going +2 and -3. Go back right 2 and down 3. If you're doing a reflection over a line and you want to get back to where you started, you reflect back over the same line. Nothing changes. And if that line is an equation, same idea, it's not going to change. If you're rotating, and it doesn't matter what the center is here, we would use the same center regardless of what we were rotating, around some center, and you use 45 degrees. To undo that, you would rotate around the same center and go -45. But also keep in mind that a rotation is a full circle, 360. So if we're going 45 degrees in one direction, another way that we could land back on where we started is to complete the circle and go the rest of that 45 degrees. And so in the same direction with the same sign, a positive 315 would also land you back where you started. Okay, same idea. If you're going in a negative direction, you could either go the opposite way, the same number of degrees, or you can complete the circle with the same sign. So a -100 and a -260 would complete the -360. Okay, for a dilation, you're going to do the reciprocal scale factor. So what happens is if you're dilating by 2, to undo that, you would dilate by the reciprocal of 2, 2 over 1. The reciprocal of that is 1/2. If you were doing 1/4, you would flip that, and you would get +4 over 1, or just 4. If you were doing a scale factor of r, which is really r over 1, then you would do the reciprocal of that, which means that you would do 1 over r. And if you had 2/3, you would do the reciprocal, which would be 3 over 2. Now, focusing on what we're doing here, we're going to be identifying a similarity transformation that will map each pre-image onto its image. To do that, one of the ways that we can constantly make sure we don't miss anything is to follow this order, TRRD. Translate, rotate, reflect, dilate. It's kind of easy to remember because it looks like turd. So if we think about doing it that way, the first thing we want to do is translate, which means that we would try to map this original triangle onto its image so that one of the corners would lock up. So I'm going to choose corner V. If I were to move V to V prime, that means that I would have to move the entire triangle right 9 and up 7. I'm not going to give the names to the corners, but I'm going to do that on the grid. And so moving it right 9 and then up 7 would land it here. And then I would have to just simply dilate it. I would use point V prime here as the center of dilation, and I would have to figure out how big to make it. So remember that when you do that, you take a length from the image, which would be like here, the 10, and put it over its corresponding length from the pre-image, which this one is 6. And then so you would put them into a fraction, image over pre-image, and simplify it. 10 over 6 simplifies to 5/3. So this would be a dilation from V prime of 5/3. And you can use the notation or you can write it out in words. That's totally up to you. Okay, going on to number 11. This is the same idea, but they're circles. So we're going to follow TRRD again. And first we're going to translate the pre-image Z, circle Z, so that the centers line up. That's what I'm going to choose to do. And to do that, I would have to count. It would go to the right 9 and then down 7. And once I do that, I would end up at this dotted circle here. And then once I completed it, I would have to dilate it. And again, just like before, I'm going to pick a segment from the image and a segment from the pre-image, and what I've used are the radii. So I'm using the radius from the image Z prime all the way out, and that's 7, and then this one is the corresponding radius, which is only 3 units. Okay, for number 12, I'm going to use that TRRD again. So the first thing I'm going to do is I'm going to shift the pre-image, regular ABC, so that some of the corners line up. Because this grid's a little bit small, instead of going to make A map onto A prime, I'm going to map A up 3 units so that it lands on B prime, and it will be here. Then I'm going to reflect it, TRRD, over this line, and I'm going to call that line L. And what will then happen is this point here, which was A originally, will flip over that line and land over here on A prime, like so. Then after I have this purple one in here, I'm going to dilate it. I'm going to use point A prime as the center because that's going to remain fixed. And then the same as before, I want to pick lengths from my pre-image and my image. So for my image, I'm going to use the length that went for A prime, B prime, all the way across here. And that would correspond to the length from AB. And so I'll figure out how long each of those is and then divide. So for A prime, B prime, it's 14, and for AB it's 7, which makes 2. For number 13, this one's a little different because there's a rotation. So I am going to follow the TRRD method because it will help guarantee that I can do this correctly. And so first I'm going to translate one corner onto another. So I'm going to move B onto Z, which means that I have to go left 1 and then up 3. And then after I do that, I am going to try to rotate it. So let me shift that up first. Then when I rotate it, I'll keep point Z fixed, and this is going to go clockwise, so negative 90 degrees. And then it will land here. And then I can dilate it. So again, point Z is the center. It's going to remain fixed. I'm going to pick 2 lengths. XZ here is 1, 2, 3, 4 units, and its corresponding part is only 2, so it's dilating by 2. Okay, same idea here. This time I already have point C connected, so I don't need to translate. I just need to rotate. Since A to A prime is clearly a straight line, and B to B prime is forming those vertical angles, I know this has to be 180 degrees around point C. When I do that, I'll get something like this. And that really can be a rough sketch, but now B ends up here and A ends up here. So then I can dilate that. Also, by the way, remember that a rotation of 180 is also the same as a point reflection. So B reflects through point C and lands in this spot. A reflects through point C and lands in this spot. And then when I dilate, it's going to be a scale factor of 2 because it does go from 5 to 10, and that's doubling. Okay. Now, We can also use construction tools to create a sequence of rigid motions. We'll come to that in a moment. If we follow the TRRD method, then first I would do something like translate to lock two corners, for example, C to C prime, getting something like this. And then I'm going to rotate it around point C. Now, another way you can describe a rotation is to say which lines would end up parallel. So if you had named these points B prime and A prime, I would then change this to double prime. And you can say so that this ends up parallel to A prime, B prime and A double prime, B double prime. And it would look something like this. And then you can do your dilation. And this time the scale factor is 5/3 because we're ending with a 5 and starting with a 3. Now to do this with construction tools, things work a little bit differently. You would first do this dilation. You work backwards. And so first you would take the original shape and you would dilate it using your compass, using the scale factor of 5/3. We're basically just to make it congruent. And then you could construct a center of rotation to do the rotation. I'll show you this on some of the future ones. So for number 16, you can do TRRD. First you would lock up your shape. So for example, you could translate so that it would become A to A prime. So it would look something like this. And then you could do your dilation centered at A prime and then just name your scale factor with the side names instead of actual lengths. If you wanted to use construction tools, in this particular case it can be pretty simple because you could just construct a center of dilation using just a ruler by figuring out where all your your vertices all line up when you do that, and then that point there can be your center of dilation, and you can just name it and talk about your scale factor and do this in a single step. Same thing for number 17. You can do the translation and dilation, or you can use construction tools to find your center of dilation and do it that way. So if you're going to name them, you would have point P here.